Hello, Paul here, K8IO. Wanted to talk about a device I found made by Electronic Research Incorporated, ERI, who is a well-noted antenna manufacturer, and they do combining systems and all kind of stuff. I found this device. It was basically surplus, never going to be used again. It was part of an antenna retrofit 15 years ago and had been laying around ever since, and I thought, I'm going to take this apart and do a little video. So what we've got here is a power divider. Takes high power RF input, and in essence it feeds a horizontal dipole and a vertical dipole, or vice versa. I'm not sure which one feeds which, but it feeds these out of phase 180 degrees from each other. And that, in essence, creates a circular polarized signal. The antenna is typically mounted on a panel, and then the dipoles mount out from the panel a certain distance. They're called, a panel antenna. And those antennas are obviously directional since they have a panel on the back of them, and you typically will find 3 or 4 of these around the tower, depending upon the size of the tower or the building or whatever. Most towers are triangular, so you'll have 3. It makes for a very robust omnidirectional signal. There will be some slight deviation in the signal, but there always is. So that's what this does, and then I will talk about why this has 3 ports and not 4, and that's why it was changed out. This antenna, as you can see, was built very robustly, and you can see the hole on the back side. This is the big hole where the RF fed in, and ERI, true to form, builds these things like a tank. So, and you can see the construction on the side. This is a plate that fit here with a gasket. I'll set that aside. It was held with screws. These are insulators. I'll talk about that more. But if you look in the end of this, you will see the hole down at the left end on the top that is the RF input, and you'll see another hole over here that is RF output, and you'll see another hole down here that is RF output. You'll notice there's no hole there. More on that. All right, so, and down to the smaller antenna flanges. And that was done because I'm sure to control weight, and there's no need for the higher power. All right. This is the inside of the device that does all the magic. And basically, this is a 3 dB combiner, or a 3 dB power divider. And the way this thing works is you take your high power RF in, and you'll notice you've got your RF is connected here, but there is no connection between this element. So your RF comes in, travels this 90 degree at FM frequency path, and comes out this port. So you've got a phase shift from here to here of 90 degrees. Okay. Now, you'll notice there's no connection here. And the reason that is because normally you would find a port to connect to a load to dissipate any power caused by an imbalance from this port to this port. But since this was going to be mounted high up on a tower, probably having a resistive load was not a good idea, and it wasn't necessary to really protect any part of the system. So ERI designed this to function without what's referred to as a dump load. Okay, so now the RF has traveled down here, and by the time the power makes its way and it gets coupled through capacitive and inductive coupling. And of course, that's putting in yet another phase shift. So the phase shift from here to here is 180 degrees. These two are out of phase with each other. So you've got 0, 90, 270, and this one down here, you notice I've got every angle covered except the 180. This would be the 180. So this port would be exactly out of phase with, this port would be exactly out of phase with the phantom port. So theoretically, there will be no power at that point if everything's balanced between these two, okay? And that's how these things work. This thing goes in the box just like this and feeds the power in. Now, the reason this device was changed out, you're probably thinking, man, the thing looks in great shape. It was. There was no problem at all with it. This was an update for technology. So basically, what ERI came up with the genius idea of doing was coming down here and putting in another port, which any power coming in here goes to the two antennas, and if the loads are balanced, there will be zero power here. And it will be, so the phase going from here to here is 0 to 90. Here to here is 0 to 270, okay? And this port is the 180 port. So if you put another port in here, you can inject low-level HD signals that are going to come in here, and the 90-degree phase shift will now be from here to here and 270 from here. And what that means is that an analog signal can go in at high power, let's say 10 kW, and will give you, for sake of discussion, a right-hand polarized circular signal, a right-hand signal. In other words, the signal is going to turn to the right as it proceeds through the atmosphere. When you feed into the theoretical port down here, the signal is going to leave, it's going to be out of phase, and it will turn in the opposite direction. Did I do that right? As it proceeds down and leaves the antenna. Depending on which signal you're detecting, it really makes no difference. However, it's kind of an ingenious system. So, power in here should not appear here. Power in here should not appear here. However, it will appear on these two antennas, but will be out of phase. So, that's how an ERI antenna combiner works. I hope that helps you understand what's going on. Like I said, this thing's built like a beast, and I'm glad I had the opportunity to maybe help you understand some of the magic of one of these things. As you can see, they're very well built and really cool devices. So let me add, if this was on the ground and being used, the other thing I've seen done is you can feed a transmitter in this port and a transmitter in this port, and as long as you have everything in phase and actually exactly balanced, your phasing. So if you have let's say you have a 5,000 watt signal and a 5,000 watt signal here, and you get everything tuned just right, and you get your drive to each transmitter in the proper phase, then it will put out all the power out this port. The problem is, and that's why you would have what they call a dump port, okay? So everything equal here would involve maximum power minus system losses out here. If, however, this transmitter would drop and this one would remain operating at 5,000 watts, you would get, because the two equal signals aren't canceling each other out, you would get 2,500 watts here from the transmitter, or 5,000 watts here from the transmitter. You would get 2,500 watts to the antenna, and you would get 2,500 watts going to a dump load. The nice thing about that system is you would still be on the air even though you lost one of your transmitters. The bad thing is you would lose 3/4 of your power, or about 4.5 dB. So, you know, but you would still be on the air. So that's how this would be used in an on-the-ground application, and why you would have a dump load on here. Since this was antennas that was completely fixed, and it's not like a transmitter that has to be tuned. In other words, once you get the antennas tuned, unless lightning hits them and burns half an element off, you're never going to have any issues. So that's the description. Here's the parts. As you can see, all very well built, made by ERI. Got any questions or comments? Put them below, and I'll try to answer them. 73 KDIO.